This is section 3.1 on tangent lines and derivative at a point. In this first diagram here, we have a slope. So this light blue line is our slope. And we have a secant line, which is just a line that goes through two different points on the curve. And the tangent of that secant line, with this distance being h, is f of x sub 0 plus h minus f of x sub 0. So in other words, you're taking y minus y, and then the x minus x would be, the x's are going to cancel out, and you would just have this h because that's in there. Now, this line, the red line, is the slope of the tangent line, and that is a limit as h approaches 0 of this same, and you should recognize that as the difference quotient. But this is the limit as h approaches 0. This is just a standard slope equation that you would use where it's y minus y over x minus x, but because you've got the h in there, those x's will cancel out. So the definition, the slope of the curve, y equals f of x at the point P, we've got this point P and this point Q. The slope is the limit as h approaches 0 of this, provided the limit exists. And the tangent line to the curve is the line through P at this slope. So the following are all interpretations for the limit of the difference quotient. And so you might read through those, but the derivative at a point, we're all talking about the slope is the derivative. The slope of the tangent line is the derivative, and that's what we're going to focus on. So let's go look at our problems for this section. All right, number 1 says find an equation for the line tangent to y equals 4 minus 3x squared at the point 4 comma negative 44. So we're going to write that and use this, the slope. We remember that to write the equation of a line, you need a slope and you need a point. We don't have the slope. So m is the limit as h approaches 0, and we've got this. So the limit as h approaches 0 of 4 minus 3, and instead of x, we've got 4 plus h. We're going to use 4 plus h as our other point, minus the y part here. All right? So all over h. So we're going to expand this 4 plus h. And why did we do 4 plus h? Because this is our x sub 0 and it's plus h. So we have to do f of that. We're going to plug in that x sub 0 plus h every time. So we've got 4 minus 3 times this is if you square this binomial, and that ends up being plus 44. Then I'm going to multiply the 3 times everything here, and I get 4 minus all of this plus 44. What happens is we've got 4 minus 48, that's a negative 44, minus 24h minus h squared plus 44. So those are going to cancel out. And we're left with this. The h's, we still can't let h go to 0 because that would be undefined. But if we factor out h on the top, so if I pull out h here, I'm left with negative 24 minus h. Then these h's can cancel out. So now I can actually take the limit as h goes to 0. I can plug in 0 for the h, and I end up with my negative 24, which is my slope. So I now have the slope, and I was given this point. So the point slope form of the equation is y minus y1 equals m times x minus x1. So we have y minus a negative 44 equals negative 24 times x minus 4. Simplify all of that, get it into the slope-intercept form, and you have y equals negative 24x plus 52. That is going to, that's going to give you your answer. Let's look at number 2. Same kind of idea. Find an equation for the tangent to the curve at the given point, and then sketch the curve and the tangent together, which means you will figure out what that will be. So we're given y equals 2 square roots of x, and the point is 1, 2. So the slope is going to be the limit as h approaches 0 of 2. And remember, instead of x, we're going to have 1 plus h. So 2 times 1 plus h minus this y value of 2, all over h. So when we want to clean that up, we need to multiply, because we're not going to get that factoring out the h that we had in the first one. We want to multiply by the conjugate of this expression. So we've got square root of 1 plus h plus 1 over the same thing. So this is like multiplying by 1, but what it's going to do is clear that out for us on top. So when you multiply that times that, the 1 plus h under the radical times that, you alleviate the radicals. So now we have 1 plus h and then a minus 1. On the bottom, we have h times all of this. Now, the 1's cancel out, and you have an h there and an h there. So the h's cancel out. So now I've got 2 times 1 over the square root of 1 plus h plus 1. I can take the limit there. I can put 0 there. And that means I have square root of 1 plus 0. So that's 1 plus 1. Now I have 2 times 1/2, which is 1. So the big thing to remember there was that algebraically, to get rid of this, we're going to multiply by the conjugate of this expression, which is the same thing, but you change this sign. All right, so then we've got our slope, we've got our point, we plug in, and we end up with y equals x plus 1. Now, if we want to try to make match the graph, it's a little tricky, but these blue ones all look like square root of x with a 2 as a multiplier, and the intersection point looks like 1, 2 on all of them. But what we need to look at is on the line that we have come up with, y equals x plus 1, it should have a y-intercept of 1. On this one, it's a little above 1. This one's exactly at 1. This one's a little below. That's something you have to look for, is the y-intercept that you've come up with needs to match here in the graph. So that should help you get that part. Let's go to number 3. Number 3, same idea. We've got y equals 2x cubed and the point 216. So this is the very same idea. You just have a little bit more algebra to do. And the algebra is sometimes what kills us, not the calculus. But we're going to, here is our x value that we use, 2 plus h. And so we're going to have 2 times 2 plus h cubed, and then minus the other y value, which is 16 over h. The limit as h goes to 0. Well, we've got to cube this thing. First, expand it, square it, and then multiply it by 2 plus h. And that is all of this that I did here, and you end up with 8 plus 12h plus 6h squared plus h cubed. Be careful. You've got to do all of that work. So in this one, I multiplied 2 by all of these pieces and got that. Then I multiplied h by all those pieces and got that. And then I added like terms, and that's how I got that. That's just straight algebra. So we now have that. Go ahead and multiply 2 times all of that. And so this is what we have here. The 16s cancel out, so we have just h's on top. Factor out the h, and you are left with 24 plus 12h plus 2h squared. And then the h's, and I didn't show that, but the h there and the h that you'd factored out are gone. So we now have this, and the limit as we take h to 0, these two terms are gone, and we're left with 24. Use your the point slope form, fill in your pieces, and you get 24x minus 32. And again, as we look, we want to be looking for a y-intercept of negative 32. We don't have that here. We don't have it here, but here on our red line, which is our tangent line, we're hitting right at negative 32. So that would help you get that one. All right, let's look at number 4. I can move a little bit. All right, find the slope of this function at 614. So again, we're doing this, and we're going to plug in x plus h for x, and we're using this one. We're doing it a little bit different. So we are just using x plus h in this one, approaching it a little bit differently, but instead, so we're going to have y minus y. This y is the original that we're given. That's your f of x. This is f of x plus h. So this is 7 times x plus h over x plus h minus 3 minus that all over h, limit as h goes to 0. So we have to kind of start cleaning up. Let's get a common denominator, which is this times this. And so if we're putting it all together, then we've got to multiply this top, 7x plus 7h, times x minus 3, common denominator. And over here, we're going to multiply by the x plus h minus 3. So we're taking and multiplying this piece times that numerator, this piece times that numerator. We have that as a denominator. Now we can start cleaning up. So we've got 7x squared, that's multiplying there, plus 7hx minus 21x minus 21h. So that was multiplying all of that, and that's what we have here. Then we have 7x squared, 7xh or hx, and 21x. And we have a minus for these two terms and a minus minus, so that becomes a plus. And we have this on the bottom. So the 7x squareds cancel out, the hx cancel out, and the 21x cancel out. And we've got that over h. So now this is what we've cleaned up. Limit as h approaches 0 of negative 21h, that's all that was left, over that denominator over h as h goes to 0. Now, that h and that h can cancel out because this thing could be right here, right? It's a double denominator, so those are going to go away. And then we can plug in 0 for this h, that's possible, and we're left with negative 21 over x minus 3 squared, because you have this x minus 3 times x minus 3. And then that's what the slope is. That's a formula, if you will, for the slope. Now, we are given x at the point 614. So at x equals 6, where is my number 4? Here we go. At x equals 6, if I plug 6 in there, I've got negative 21 over 6 minus 3 squared. So that's negative 21 over 9. That is my slope. I had to get the general equation for it, and then at any point I can get a specific slope. Then you plug into your point slope form and algebraically clean it up, and you do get negative 21 over 9x plus 252 over 9. It's going to expect fractions in your answers, not decimals. So be sure you're paying attention to that. All right, number 5. So each time we're doing a little differently, or maybe we're asked to do a little more. Find the slope of the following curve at x equals 6. So we aren't given a full point. We don't have the y coordinate. So one of the first things to do is figure out when x is 6, what is f of x? So you plug 6 in for the x here, and you get 1 over 4. So your y part of the point at 6 is 1/4. All right, now if we follow this, limit as x approaches 0, 1 over 6 plus h minus 2 minus, we can do the 1/4 over h. So this is 1 over h plus 4 minus 1/4 over h. We need to do a common denominator, which is 4 times this. So we end up multiplying this denominator here, this denominator here. So we have 4 minus h plus 4 over the common denominator, 4 times h plus 4, all over h. So up here, the 4's cancel out, and we're left with negative h over 4 times h plus 4 times 1 over h. We just brought that up this way. The h's cancel out. We're left with negative 1 over 4h plus 16. As h goes to 0 now, we can have negative 1 over 16. We aren't asked to write the equation of the line. We are just asked to find the slope at that particular x value. So the answer is negative 1 over 16. All right, number 6. An object is dropped from the top of a cliff 640 meters high. Its height above the ground t seconds after it is dropped is, and so our height is here. Determine its speed 3 seconds after it's dropped. So when t is 3, s of 3, plug in, and you get 595.9. And so you got there. Now, it wants to know the speed 3 seconds after it's dropped, the speed. Okay, so we have to do a little bit of work here. All right, so what we want to think about, they gave us the distance, the height, and we're finding its instantaneous speed at 3 seconds. So we know the position at 3 seconds would be 595.9. We can plug that in. So we need to find the instantaneous speed by taking the derivative of this thing. So we're going to take the limit as h approaches 0, s of 3 plus h minus s of 3 over h. And this is 640 minus 4.9 times 3 plus h squared. Okay, so that's this. 640 minus 4.9 times t squared, and there's our t, 3 plus h, minus an s of 3 was 595.9 all over h. So we kind of clean this up on the top, do our math, and we end up with 44.1 minus 44.1, and these with h terms. Those cancel out. We've got negative 29.4h minus 4.9h squared over h. If we factor out h here, we're left with h and this and an h on the bottom. When those cancel out, we can now plug in h to be 0. And when we take 0, can't get my mouse down there, and put 0 here, then we have negative 29.4 is the instantaneous speed, and the negative is going to indicate that we're falling down. So what we did was really not much different, but we did have to get our y value here. We plugged in the 3, and then we took the derivative, doing like we've been doing. All right, let's look at number 7. What is the rate of change of the area of a circle, a equals pi r squared, with respect to the radius when the radius is r equals 3? So first of all, we need to go ahead and plug in when r is 3, right here. What is a? Well, a is pi r squared, so a is going to be 9 pi. So we're taking the limit as h approaches 0, f of 3 plus h minus f of 3 all over h. And it's pi r squared is the formula we're using. So we've got pi times 3 plus h squared minus this one, which is 9 pi over h. Expand this, you get 9 plus 6h plus h squared. You have the pi on the outside, and you have minus 9 pi. When we multiply this by pi, we end up with this line. The 9 pi and the negative 9 pi cancel out. We've got this over h. If we factor out the h, we are left with 6 pi plus pi h. We can now let h go to 0. See, when we start out, we can never let h go to 0 because it's down here. But here we can, and we're left with 6 pi. So the area changes at a rate of 6 pi. All right, number 8. We're going to use our calculator here. Use technology to answer the following. Graph the curve y equals 5 times x minus 1 to the 2/5. Where does it appear to have vertical tangents? Confirm with limit calculations. So when we graph it, and I just did a screenshot of my emulator here, it appears to have a point here at x equals 1. So if we take the limit as h approaches 0 of f of 1 plus h minus f of 1 all over h, so we're going to have 5h to the 2/5, these ones canceled out, over h, and that was minus 0. And then, so we have h to the 2/5 over h to the 5/5, which gives us, so we're trying to clean this up, and we have h to the negative 3/5. We don't want a negative, so it's going to stay on the bottom. So we have 5 over h to the 3/5. And while we can't plug in 0, we can look at that on the graph. As you approach 0 from the left of this graph, you're going towards negative infinity, and as you approach 0 from the right, you're going to positive infinity. And so different things on either side. The limit does not exist, and there is no vertical tangent. I believe that's probably a pull-down menu, and that's what we would get. So I think that will get you 3.1 and get us started in chapter 3.